Let's talk about pointers in a conceptual level. Now, remember that when we're talking about memory, it's basically a giant pool of bits that we can use. And typically, whenever we declare a variable, if I do something like this, and health is equal to 1, this will give me a specific spot in memory. Now, if this is a 32-bit integer, this will be 32 bits in size, and this is essentially where my health variable will be stored. So this will be a whole bunch of zeros, dot, 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 0, 0, 1, because this currently has a value of 1. Now, this health variable is at a specific location in memory. This thing has a memory address associated with it. Now, I'm just making up a number here, FF2A12, right? Let's just imagine that this is the hexadecimal address for this, this variable here, health, and where it's stored in memory. Now, a pointer is incredibly powerful, and we use them all the time in C++. The foundational concept behind it is that when you declare a pointer, it's not so much storing a value, it's storing a memory address to another value. So, as an example, if I declare a pointer like this, int star with an asterisk next to it, hptr for my health pointer, right? Now, this health pointer, this thing is going to store a memory address. So your next question is going to be, well, this integer, Dave, you said it was 32 bits, so this takes up 32 bits in space. Well, this is a pointer, right? It's not an integer. One thing to really note is that an integer pointer is different than an integer. It's a completely different type. So how much space in memory does an integer pointer take up? Well, this thing needs to store a memory address. So it's however much space I need to store this. This is actually the difference between a 32-bit operating system and a 64-bit operating system. It's the size of your pointers, or the sizes of your memory addresses. So let's say that this is a 32-bit operating system, so this thing takes up 32 bits in memory, right? Here's my H pointer, and it's here in memory. And this thing has its own memory address, whatever that is, right? I don't really care about it, but this pointer does have its own memory address. Obviously, it's got to be stored somewhere. So the next thing is, well, what can I do with a pointer? Well, pointers store memory addresses. They don't store actual data. So I can store the address of health. Now, this is my really bad ampersand, but the ampersand in C++, however I draw that, is equal to two things. One is it's the address of operator. The address of operator. So if I use it to the left side of a variable like this, I'm asking for the address of health. This pointer is equal to the address of health. Well, that's this thing, 0xFF2A12. This pointer, the value that this pointer is going to have in memory is 0xFF2A12. So if I were to print out the data that this pointer has, it would print out 0xFF2A12. Great. Now what does that get me? Well, it's another way to reference this health variable. The other thing that we can do is we can use that asterisk, the same one that we use to initialize an integer, we can use this to dereference. We're going to use it to dereference that pointer. I can do something like this. hptr. Now remember that this is the variable. This is this value, 0xFF2A12. If I dereference it and assign it to a value of 2, I write a line of code that looks like this. What this is going to do is it's going to say, let's look at the memory address that hptr has, 0xFF2A12. We're going to dereference it, which means that my computer is going to jump to that memory address. And it's going to assign the value of 2. So I'm going to take whatever here is in the same position as health and update it to the value of 2. This is another way to reference and point to blocks of memory. And we'll get more deep into this and why pointers are so important in other videos.